All right. Theodore. All right, not here today. All right. So then we got Kevin, we got Sam, and we got Zachary, right? Zachary or Zach, do you have a preference? Zach? Okay. All right. Jules? All right. No Aiden today? All right. Alicio? Okay. Abigail? You prefer Abigail? Abby? Abby is fine. Okay. Thank you. It's all. Good morning. Elsa? Nope. And then Charmante? Nope. 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 All right. All right. Cameron? Right? Okay. Evelyn? Okay. All right. Finlay? Finley. Finley. I'm sorry. It throws me the way it's spelled. I'm sorry. All right. Adriana. Okay. Ray.
Here.
Karina. Giselle.
Here.
Okay. And Shining.
Here.
Thank you. Albert. All right. Estefani.
Here.
Yep. Skylar.
Here.
And Adriana. Sign that one more time. Adriana. Okay. Thank you. Correct me if I'm wrong, because with Adriana and Adriana in the same room, I'm going to have to do some work on that. All right. So we'll do that. All right. All right. Well, welcome back to the second day, ladies and gentlemen. We got a lot of things accomplished yesterday. We're going to get a bunch more accomplished today. Today we're going to start talking about units. We're going to get into metric conversions, and we're actually going to get some practice in on those things. Yesterday we went through a bunch of vocabulary. I did in Canvas this morning put something out there for you, and that is in the modules I put out a link to some vocabulary flashcards through Quizlet. So it's a link. When you click on it, ladies and gentlemen, you have a link here that'll take you to Quizlet, and you can use the flashcards to practice some of the vocabulary. I would love to tell you there is a great way to learn vocabulary, but I don't know what it is other than repetition. Okay? Now, again, you should be familiar with a lot of this vocabulary, but if you're not, there is vocabulary there. One thing I should mention, too. There are 3 terms that we did not define that were in your EISN. We did not define accuracy, we did not define precision, and we did not define significant figures. We will get to those. Those are 3 topics that we have coming up, okay? I do have those in these flashcards, though, only because I didn't want to redo my flashcard set for you. But understand that probably later part of next week, we'll be taking a short quiz on the vocabulary and things, okay? Those 3 terms will not be on your vocabulary: accuracy, precision, and sig figs, unless we get to them before then, and I would let you know that, okay? But things like control, constant, experiment, hypothesis, independent, dependent variable, those are the things that are going to be on your quiz, the vocabulary that's going to be there. So again, these are flashcards that can help you study that. So again, you've got the flashcard here with the definition on it, and then if you click on it, on the back side is the term that it goes with. And you can do it either way you want. You can either have it so that it's giving you the term and you supply the definition, or the definition and then you supply the term. Again, just there for you if you need it, if you want to do it, if you want to go through it. Sorry, didn't hear or not. Good morning.
Good morning.
Come on in, come on in, come on in. Okay. So that's out there for you to help you get ready for the quiz and things. Okay? Questions? Excellent. All right, so my question of the day today is this. Name me a unit and tell me something it measures.
Second.
What?
Second.
Seconds. What's it measure?
Time.
Time. Good. Give me another unit. Tell me something it measures.
Height or width.
Okay, what would we use to measure those though? So what unit do they measure your height in?
Distance. Or
Oh.
not distance, sorry.
You are right about distance, height, and like width. Those are all distances. But what do we measure distance? Well, when you go to the doctor's office, what do they measure your height in? What unit do they tell you? Inches, feet, inches, something like that. Okay? So those are units. They describe height, they describe length, they describe distance, all of those things. Okay? Good. What else? Liters. What does it describe? What about a liquid though? You're absolutely correct. Liters is normally used to describe liquids, sometimes gases. But what does it actually describe about the liquid? Describes its volume, how much space it takes up. Good. Couple more. What?
Weight.
Okay, what unit do we use to describe weight?
Pounds.
We use pounds to describe weight. Very good. Give me two more.
Kilogram.
What?
Kilogram.
Kilogram. What do we use to describe it? Or what? It's a unit. What does it describe about something?
Mass.
It describes mass. Now, mass and weight, slightly different in science. We'll get into explaining that a little bit later. But we use pounds to describe weight. We use kilograms to describe mass. All right, one more. What's it?
Ounces.
Ounces. Ounces describe what?
How much something weighs.
Okay. How much something weighs in what?
Like a small proportion.
Okay, like a smaller amount. And actually, here's the thing about, there are two systems for measuring. One is called the metric system. One is called our standard system, which we use in the U.S. The U.S. system gets confusing, though, because actually the unit of ounces is actually used twice in our system. It describes weight. So in other words, 16 ounces is 1 pound. Okay? So 8 ounces is a half a pound. But ounces is also used to describe volume in the United States. So for example, a 12-ounce soda has nothing to do with its weight. It is a totally different unit, same name, but it describes the volume of how much soda you are drinking. Okay? In the metric system, that never happens. No unit is like used in two different measurements. Okay? So in a lot of ways, the metric system is a little bit easier. Okay? Questions? All right. So at the end of the day yesterday, we had you taking down and writing different kinds of measurements. Different things that we measure. Today we are going to talk about that. So if you would open up your EISN, your Electronic Interactive Science Notebook. And again, you can find it through Canvas, ladies and gentlemen, by going into the modules. And it is right here. Again, once you open it up once, you may want to do a bookmark to save it. Yes. Sure. Okay. You may want to do a bookmark to save it just to make it easier for you to find it later on, but that is 100% your choice. So where we are starting, ladies and gentlemen, is here. We're on slide number 12, and I believe your slide 12 and my slide 12 should be the same. I think, if I'm not mistaken. If I'm wrong, please tell me. Okay. But this is where we are going to start. We're going to talk about measurements today. Now, if you're sitting in the front of the room, you picked a really good spot. Why? Because on that poster up there are the 7 base units that we measure in science. So if you can see that from where you're sitting, the good news is when I ask you that on the test, you should be able to copy the answers down right from there. Okay? If you're in the back of the room and you can't see that, sorry, you picked a bad spot. Okay? So maybe on test day you want to get to a different spot. Okay? But there are 7 basic units or 7 basic types of measurements that we make in science class. And here we go, ladies and gentlemen. Once I turn that on, here they are. Okay? This is all 7 of them. And I believe you have a chart like this that you have to fill in on a slide.
Yeah.
Okay, I'm going to be quiet for the next few minutes and let you fill this in. Bless you. Anyone need more time? Google has made these obsolete, ladies and gentlemen. When I was a student, yes, a long, long, long time ago, we didn't have computers that we had in class. Okay? The first computer that came into my school when I was in about, I think, fourth or fifth grade, and all you could do on it was very little. We could make the screen display the same word all over the place. That was about the best we could do with it. Okay? And now you guys have computers that, in my cell phone, it has more memory than the first computer I ever owned had. Okay? That's how far we've come in a few years. But this is a book that has all kinds of numbers in it, and we'll talk about it in a few days when we get into things. You guys can look things up on Google. When I was a kid, if I wanted to look up the boiling point of an element, I had to go into here because it's in here. Okay? Boiling point, melting points, things like that. You guys can type into Google, what's the boiling point of mercury? And it will tell you what the boiling point of mercury is. Okay? And I tell you this not so you feel sorry for me, but I tell you this to give you a visual because Mr. Arts, who used to teach chemistry next door, had a book like this, and it was filled with units. Units to measure things. Okay? And people ask, why are there so many units in the world? And really the answer is quite simple. Every culture years ago used to have their own way of measuring things. Everybody had to measure distances or length, but every culture had to come up with their own way of doing it. And then as the world started to unite, and as this country started talking to this country, and that country started talking with this country, all of a sudden they're like, when they would talk about measuring things, they would be like, well, we use foot. Well, we use meter. Okay? And then they had to find a way to meld these systems together. Okay? By the way, anybody know why in the US system we call a distance a foot? Because it was simple. In England, they measured a foot by the size of the king's foot. That's how they used to measure things. So if you wanted something built by a carpenter, he would literally walk out, okay, that's 4 feet long. They used to use a unit called the cubit. The cubit was from the elbow to the tip of your longest finger. So if you went to some carpenter and said, I want you to build a table for me that's 5 cubits long, he would lay his arm on the table 5 times. Now what's wrong with that? What?
It's inaccurate.
Why?
Different people have different.
Thank you. Theodore, can you put your arm up next to mine, please? Okay, who's getting a bigger table if it's built for you? Built by Theodore or built by me?
You.
Yeah. Okay. So everybody has different foot sizes, everybody has different sizes. But it was the only thing you had to measure things with. So that is how carpenters and people would measure things. Okay? Well, years ago they decided in science we can't have this. We can't have you calling a foot this distance and someone else calling a foot this distance, and then we're trying to talk about things. So they decided to standardize the units. And that's what we have here. These are the 7 base units. Now, I'm not going to give it to you, but each one of them has a long definition of what it actually means to be that unit and how it is actually measured. And just as an example, the unit of second is the number of times that a specific cesium atom will vibrate back and forth. Okay? That's how they measure a second. A kilogram is a mass that literally is stored in a sealed container somewhere, I think it's in France, that we said, okay, this is how much a kilogram is, and every balance was set to be equal to that mass when you have 1 kilogram on it. Okay? Now they don't need to go back to that 1 kilogram anymore because they made copies of it and they balanced it out and they have them in different places. But the point being, there is one standard for each of these measurements. Unlike years ago, where a cubit was different from person to person, a foot was different from person to person. Okay? So these are the 7 base units that they use in science, ladies and gentlemen. And that is all of them. There are only 7 of them. Now, in this class, we will probably only use 3. We will use meter. Okay? Actually, we'll use centimeters, smaller. But we will use meters. We will use kilograms, but we will use the smaller version of it, grams, when we measure on a balance. And we will measure temperature, but we will not do it in Kelvin, we will do it in degrees Celsius. So I know that's confusing because I just gave you 3 units and said, well, we really don't use these, but we use a form of them. Seconds, we don't use a lot in here. If you take physics, you'll use it quite a bit. Okay? But we do time things occasionally, and that one we will occasionally use. We never measure candela. We never measure light intensity. Any idea what profession does? You all either had one or are going to have one in the next few weeks done. The photographers. When they come out and set up their lights, they have a meter that they hold in their hand, and they measure how much light intensity is coming, and they adjust it so they can set their cameras the right way. Okay? Ampere measures electric current. That is something that you will use in your homes. If you have in your basement, you have a circuit breaker board, a fuse box. It has amperes measured on the outside for how much electric current goes through things. By the way, I forgot, we will use mole. This one we will use a ton. Okay? We will use a ton. One of the things I want you to understand, for every unit, there is a type of measurement. And for every unit and type of measurement, there is an instrument that measures it. Okay? So those 3 things go together. So when you look on the back table and you see those balances on the tables, you're thinking that measures mass. And the unit is kilograms or grams. When I give you a meter stick, you're thinking this measures distance, and the unit is going to be centimeters. When I give you a thermometer, it measures temperature. The unit is going to be, in that case, degrees Celsius. Okay? So all these things have a connection. Okay? So these are two kinds of balances that you can use. But a balance means you're measuring mass, and if you're measuring mass, you're doing it in grams or kilograms. Now, the reason the base unit is kilograms is because of the physicists in the world. In physics, they talk about bodies in motion, which are heavier. So they measure those in kilograms. In chemistry class, we measure things out in grams because we're talking about using 50 grams, 100 grams of something, much smaller amounts. These are all 4 different instruments that can be used to measure distance. And I don't care if you call it length, width, height, thickness, I don't care. Those are all distances. Okay? All distances. Ruler. This is called a micrometer, ladies and gentlemen. This can read the thickness of a hair on your head. Okay? This is called a caliper, and it can measure the distance of, like, inside a hole, outside, small amounts in very precise. And then you guys have all seen rulers or tape measures before. Stopwatch measures time. Now, time is the one weird one, ladies and gentlemen. Because all of the others, a meter, you just keep getting bigger and bigger. But with seconds, what do you eventually become if you're measuring in seconds and you go long enough? And then you become days. And that is the one in the metric system that is not based on the number 10. Everything in the metric system is based on the number 10 except for time. Time is 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. Okay? So it is the one that is a little bit weird. Thermometers, ladies and gentlemen. We have digital, we have regular. Thermometers measure temperature, and temperature is in Kelvin. But
Jules, wake up! Sorry, she was sleeping.
You do not need to do that.
Yes, you do.
I want to make sure you're paying attention. Mr. Brand and me, I know sometimes get a little.
Excuse me?
Just saying.
Get a little what?
I agree with her.
Get a little what? You agree
Exciting.
with her, you should be able to
Exciting.
answer that question, Jules.
You get exciting. Woo!
If she falls asleep again, then she has to come up and perform her rap that she did at Trees
No, please don't make me do that.
But it was amazing.
No, please don't make me do
I
that.
got a water bottle in the front. I can wake her up one way or another.
No, I'm okay.
Love you, Jules.
I don't need to do my rap. That's okay.
Okay. So anyway, ladies and gentlemen, there's actually 3 scales for temperature. There's degrees Celsius, there's degrees Fahrenheit, and there's Kelvin. 3 different scientists set up 3 different scales. Okay? These 2 were set up the same way. They were set up based on water and the temperature it freezes at and the temperature that it boils at. Why? Because water is a common substance on Earth. This scientist set it up a different way. He set it up based on the motion of particles in matter. So his system is different than these 2. What's the boiling point of water in Celsius? What temperature does water boil at? Come on, nice, easy, round number. Good, 100. Thank you. You guys are great this morning. Great. What does it measure? What does it boil at in Fahrenheit? Yep, 212. 212. Don't ask me why Fahrenheit picked 212, but he did. Okay? That was the number he picked when he measured boiling water. Kelvin, 373. Now, freezing. Okay, don't mess this one up. What temperature does water freeze at in Celsius? 0. Very good. What is it in Fahrenheit? 32. Very good. What is it in Kelvin? 273. Okay? So what do you notice about here? How many degrees is this? From 0 to 100. Don't take too long. Think about it. Simple math. 0 to 100. 0 to 100. Good, 100 degrees. You guys are going to struggle in here. 273 to 373. How many degrees? That's 100 as well. So a 1 degree change here is the same as a 1 change in Kelvin. Okay? So Kelvin just used higher numbers than here. Okay. Absolute 0. Somebody tell me what absolute 0 is. Absolute 0 is the lowest temperature possible. Matter cannot get any colder than absolute zero. It is the lowest possible temperature. In Celsius, absolute zero, minus 273 degrees Celsius. Now we measure weather in Fahrenheit, correct? Cold day, you wake up middle of January, it's a cold day and you're hoping there is no school. Normally that happens when it's minus 40, minus 50 degrees below zero, correct? Absolute zero, minus 459 degrees. That's cold, ladies and gentlemen. And it's called absolute zero because in the Kelvin scale, what's the temperature for absolute zero? Zero. Zero. Okay? Now people always ask me, well, Mr. Brand, if it got that cold, would we die? We would die long before that, ladies and gentlemen. Because at about minus 189 degrees Celsius, all the oxygen in the air will turn from a gas into a liquid, and you and I will have nothing to breathe. So we will die at that point. Okay? There will be no oxygen in the air. We will have nothing to breathe. We would die at that point long before we get to the negative 459 degrees Fahrenheit or the negative 273 Kelvin. Okay? Cheery note for a wonderful morning. All right, moving on. We won't ever talk after this unit about electric current, but these are ammeters and they measure amperes, which is the unit for electric current. This is a light meter or luminescence meter, measures light intensity. By the way, where do you think the term candela or the unit candela comes from? Come on, it's right there for you.
Candle.
Candle.
Oh, candle?
Candle.
It's not how you spell candle.
No, it isn't, but they called it, a candela is the unit that one candle would give off in a dark room. That's the amount of light that one candle would give off in a dark room was called a candela. If you had two candles in the room, that was two candelas, 3, 3. Okay? Why? Years ago, they didn't have electricity.
That's true.
Mole, ladies and gentlemen. Mole is one of the units that we are going to use all the time in the second half of this course. In the second trimester, we are going to talk about moles. You're going to hate them. Okay? You're going to get to the point where you either hate them or you love them because they're used all the time. Mole is simply a counting number. How many eggs are here? How many? 12. What's another way of saying that? A dozen. If you talk about a dozen of something, you are talking about 12 of them. I don't care what you're talking about. A dozen students, you got 12 of them. A dozen eggs, you got 12 of them. A dozen golf balls, you got 12 of them. Dozen means 12, right? Mole means 6.02 times 10 to the 23rd. That is what mole means. That many pieces of something. That is a lot, ladies and gentlemen. That is an incredibly large amount. What do we measure in chemistry that we need that large a number for? Give it a shot. You got nothing to lose. If you're wrong and you die, I won't ever make you answer another question in class again. What? So a double bonus for me. Come on. What do we measure in chemistry that we need that big a number for? Something. Something really, really, really small. Particles. What are the particles that makes things up? Starts with A, ends with Toms. Atoms. Very good. You guys are catching on. Wonderful, wonderful, wonderful. Questions? Okay. By the way, those are the only 7 base units. That's it. There are no more. Well, wait a minute. We talked this morning about liters, right? What does liter measure? So you're telling me we can't measure volume? No, we can, but it's not a base unit. It's not a base unit, okay? There are only 7 base units. We just gave them all to you, okay? They only measure one thing. That's all they measure, one thing. Meter measures distance. Temperature measures, the thermometer measures temperature, things like that. Seconds is measuring time, okay? They're taken with an instrument. All of these measurements have to be taken with an instrument, and examples are meter, second, Kelvin. Kilogram. Why kilogram is there? It has these little star by it. It's the only one that has a prefix with it. It's the only base unit that has a prefix with it. But there are a lot more units out there, ladies and gentlemen. That book would be a lot smaller if there were only 7 kinds of units, but there are not. There are lots of different units out there, but they are what is called derived units. And there are millions of different derived units. And they are created by the multiplication or division of base units. How do you find the volume of a square or a rectangular object? Come on, your math teachers are somewhere going, they know this!
Length times width times height.
Thank you. Length times width times height. What is length? What are you measuring with length?
Distance.
Distance. What are you measuring with height? Distance. What are you measuring with width? Distance. You're taking the same measurement 3 times and multiplying it. That is a derived unit, ladies and gentlemen. That is a derived unit. If you want to find the area of something, you take length times width. You're taking distance times distance. That's a derived unit. You want to find out how fast you were driving on the way here this morning. You take distance divided by time. Base unit divided by base unit. Derived unit, ladies and gentlemen. Derived unit. There are lots of these. There are lots of these. Again, they have to be taken with an instrument. Actually, with multiple instruments. Because we don't measure distance and time with the same instrument. Okay? They may sound like a base unit. So, for example, liter. It sounds like only one thing, right? But it's not. It's actually length times width times height. It's a volume. Okay? Common derived units may be given a single name, such as a joule. This, right here, is a joule. These are the units that make it up. Kilograms times meters over seconds squared. You got to measure all 3 of those to get a joule. But people don't want to say kilograms times meters per second squared all the time, so we give it a special name. We call it a joule. And that's what I mean by it may sound like it's a single unit, but it is not. How do you know if it's a base unit? It's got to be one of those 7. If it isn't, it's derived. Okay? Got to be one of those 7. If not, it's derived. There are only 7 base units. Questions? All right. So, things like liter, things like watt, things like Newton, things like atmosphere. Again, I'm not expecting you to know these right now, but we may use some of them throughout the course of this trimester. Questions? All right. So, here we go, ladies and gentlemen. Now we're getting to metric prefixes, and I promise I'm going to get you up and moving in the back of the room in just a few minutes. We're doing some practice, okay? This is the metric prefixes that we use. Now understand, are these all of the metric prefixes? No. There is a metric prefix for every place in the number line. There's a metric prefix for 1,000,000. There's a metric prefix for 1,000,000,000. There's a metric prefix for 1,000,000,000,000. I don't care what they are. What I care about is, can you use them to get from one metric unit to another? Now, if you learned a system where you simply slide the decimal based on this, I don't care if you use it in this class or not. But at some point, you're going to need to have to convert between a milliliter and a liter. At some point, you're going to be asked to convert between kilograms and grams. At some point, you're going to ask to convert from centimeters to meters in this class. Now, understand, there are other units out there, or other prefixes out there. Kilo, hecto, or hecta, I've seen it written both ways depending on the text. Deca, I've seen it with a K and I've seen it with a C, again, depending on what the text is. Deci, centi, and milli. The nice part about the metric system is everything is what is called base 10. Meaning things are 10 times, 100 times, 1,000 times larger, 10 times, 100 times, 1,000 times smaller. If we are measuring a small distance in the United States, what unit do we use to measure a quarter? What unit would we use? The distance for a quarter.
Centimeter.
No, not in the US. We would use inches. If we were measuring the height of that door, we would measure it in feet. If we were measuring the distance from here to Chicago, we would measure that in miles. Now, here's the problem with the United States system. There are 12 inches in a foot. There are 5,280 feet in a mile. That is confusing. Why? Don't ask me why. That's just what they pick. In the metric system, there are 100 centimeters in 1 meter. 100. And there are 1,000 meters in a kilometer. Everything is either 10, 100, or 1,000 times bigger or smaller. Okay? Now, I am going to show you how to use these conversions to get from one unit to another today. This is the fact, though. 100 meters equals 1,000 meters equals 1 kilometer. That never changes. But that is what we are going to use if we're going to go from meters to kilometers or kilometers to meters. Okay? If you ever are exposed to a hectometer, and here's what I'm going to tell you. Nobody uses hectometers. Nobody. But they exist. But there are only 100 meters in 1 hectometer. Nobody uses decameters, but if you did, there are 10 meters in 1 decameter. Everything 10, 100, 1,000 times bigger. Or 10, 100, 1,000 times smaller. Now, the reason I point this out for you is this is where you're going to get the conversions on your worksheet from. This is where you are going to get the conversions from that you're going to do on your worksheet. Okay? So, this is where they come from. Now, you are going to find the unit that you are in. So, for example, if it says 3.25 centimeters, you are in the centimeters unit. That's what I mean by find the unit you are in. And then you are going to find the unit that you are asked to go to. Maybe you're asked to go from centimeters to the central unit of meters. That is this conversion right here. Maybe you're asked to go from kilometers to meters. That is this conversion right here. Maybe you are asked to go from grams to kilograms. That is that conversion right there. Now, I will be honest with you. The ones that are highlighted in orange, or whatever color that is, those are the ones that we will use the most in class. And it will get to the point where you will not have to show me how you do these. I assume you know how to do them and you'll do them. But for now, we're going to practice some things. Okay? Now, also, I will never tell you how many kilometers there are in a millimeter or how many millimeters there are in a kilometer. I don't even know. I don't know what the number is. But I can always take and go from any of these 3 units to the central unit and from the central unit to any of these. So the worst case scenario, this is a 2-step problem. Normally it's a 1. We're going to show you the steps you use. Okay? We're going to show you the steps you use. So here we go, ladies and gentlemen. Okay? We're going to convert 0.985 liters into milliliters. That is what we are going to do. Now, is this one done on your slide for you? No? Okay. If you have a hard time, typing in that box and formatting things, that's fine. You can do the best you can. Otherwise, you can just pay attention. We'll go to the worksheets in a minute, and that's where you'll be able to write these problems out. Okay? So, here's what we begin with, ladies and gentlemen. To go from milliliter or liters into milliliters, I need a relationship between the two. This is the relationship between the two. And where did I get it from? I got it from down here. To go from liters to milliliters, this is the relationship between these two. 1,000 milliliters equals 1 liter. So that is what I'm going to use to get from 0.985 liters into milliliters. Now, I'm going to show you how I am going to do this, how I would like you to set these up. And you may be like, Mr. Brand, it's much easier for me to just slide the decimal. And if that's the case, so be it. But I'm also teaching you a method that you're going to use later on in this class. And that's what I hope you will be patient for me with right now. All right. So here we go, ladies and gentlemen. All right. So I have the, come on. Oh, it's help if I would turn my thing on. All right. So, I am going from liters to milliliters. So I start out by writing the number I am beginning with down, 0.985 liters. And now I am going to take this fact here and make a fraction out of it. Now, how I determine what goes where is simple, what is called unit cancellation. What unit is that number in? What is the unit for that 0.985? What? Liters. So I have milliliters and liters in my fact that the two are equal to each other, correct? I am going to take and put liters on the bottom of my fraction because that is the only way that these two units will cancel out. So I'm going to take this 1 liter and I'm going to put it on the bottom. The other part I'm going to put on the top, the 1,000 milliliters. And now, ladies and gentlemen, I have canceled out the unit of liters and I am left in the unit of milliliters, which is what I was trying to get to. Now, mathematically, I take 0.985 times 1,000. What's 0.985 times 1,000? This is where my heart always sinks. Thank you, 985. And somebody's going, well, all you did was slide the decimal 3 places. Yeah, because there's 3 zeros here. That's all I did. Okay? That's all I did. The unit that is here has to go down here. Why? Otherwise, they will not cancel. Otherwise, they will not cancel. Okay? So, let's go back 1 second. Can I take this away or do you still need it for a moment? Come on. 7. Thank you. 1. Thank you, Sam. 1. Good, good. Abby's participating now too. Great, great, great. Are we seeing a pattern? If the top of the fraction and the bottom of the fraction are equal, what does that mean? That it's 1, correct? All right, here's the hard one. Four quarters, $1. No, it's still 1. Aren't those the same thing? Isn't 4 quarters the same thing as $1? So anytime I have come on. This is equal to that. This divided by that equals what? If they're equal, what does this equal? 1. What if I put that over this? Still 1. That's what we're doing with unit cancellation, ladies and gentlemen. We have two things that are equal to each other, and we are using them to convert from one unit to another. Now, if you have 4 quarters in your pocket, you have $1 basically, correct? $1's worth of money. They're equal to each other. Now, granted, $1 is only a smaller number, but it is a larger bill, correct? And that's what this is about. In unit cancellation, we're taking a larger number of a smaller unit and comparing it to a smaller number of a larger unit, and they're equal to each other. So we can use that to take and go back and forth. All right. So let's see. So we're going to convert 3,625 grams into kilograms here. Now, again, where do I get this conversion? Where do I get this from, ladies and gentlemen? Whoop, Sorry. Boom. Let's go back. This here, that might be the ugliest line I've ever written. This here comes from down here, ladies and gentlemen. Right there. That's how those two things are related. So 3,625 grams. I'm going to take and make a conversion factor out of this. Which part of this 1,000 grams or 1 kilogram has to go on the bottom? The grams. 1,000 grams. What goes on the top? 1 kilogram. Grams and grams cancel out. Now, here's the thing. People now go, well, Mr. Brown, how do I know if I multiply or divide by 1,000? Okay, fair enough question. What is the easiest way to handle a fraction if you are multiplying by a fraction? What can you always do? Well, you can multiply by the top and then divide by the bottom of the fraction. But tell me this, is there any reason in the world to ever multiply by 1? Doesn't change the number, does it? Is there any reason in the world to ever divide by 1? No. So the nice part about this conversion is you're going to have a 1 somewhere in it. If the 1 is on the top, what it means is divide by the number on the bottom. In the last one, the 1 was on the bottom. It means multiply by the number that's on top. Right? You're actually doing both, but you don't have to go through that step. Well, I multiplied by 1,000. Now I got to divide by 1. It isn't going to change anything. So what would our answer be here?
It would be 3,625.
That's what it already is, though. 3.625. The unit? Kilograms. Number got smaller because the unit got bigger, ladies and gentlemen. Number got smaller because the unit got bigger. Okay? Questions? Take out the packet that I gave you yesterday, ladies and gentlemen. Can I take this away or does anyone need this still? So let's do the packet that I gave you yesterday, ladies and gentlemen. All right. Get to the worksheet that says metric conversions. I believe it's the 3rd or 4th page in your packet. Okay. Now, the only thing you need your computers for, if you want them, ladies and gentlemen, is you could go back to this slide here just to see this table because that's where we're going to get our facts from here. Okay. That's where we are going to get our facts from. I've worked example A for you in this problem. Now, again, up at the top, it says complete each section, show work, circle your answer. You don't have to worry about doing it on attached paper because this is the attached paper, okay? So these first few, they want you to convert the following measurements into grams. So that is what we are doing on here is we are converting everything that we're given into grams. So that's why milligrams is going to go into grams. That's why I use this relationship here. I took the 92 milligrams. I took this conversion right here. I put milligrams on the bottom and grams on the top so that milligrams would cancel. That's how I got the number I did here. I took 92 divided by 1,000. Yes, it is weird to write 0.092, but you could do that. Okay? You could do that. Would we ever measure the distance from here to Chicago in feet? No, but you could figure it out if you wanted to. Why don't we? Because it would be too large a number, correct? So we use a bigger unit. Well, that's what we're doing here. Changing the unit, changing the number. But this means the same mass as this. Okay? It's just a different unit and the number is changed slightly. All right? So let's go to the next one, ladies and gentlemen. Now, I need someone to tell me how many centigrams there are in a gram. What? There are 100 centigrams in a gram. Very good. So this is the first thing you need to do. Whoops, sorry. 100 centigrams equals 1 gram. Okay? You're going to want to write that down because that's what we're going to use to get from the unit that we are starting and into the unit that we want to get to. And why are we going into grams? Because all of these problems asked us to go into grams. Okay? So we are going to take 58 centigrams and we are going to take it times a fraction. This is the information that's going to go in the fraction. Does anyone have any question about where I got this from? Okay, good. So, since I got this from the list, now which part of this goes on the bottom? And I always start with which part goes on the bottom because that's the unit that I'm trying to cancel. I'm trying to cancel this centigrams. So centigrams has to go here. The other half of this goes on top, 1 gram. Now, am I going to take 58 and multiply by 100 or divide by 100? We're going to divide by 100, which means I'm going to get 0.58 grams in the end. That is what I am going to end up with. Questions? All right. What is the relationship between decigrams and grams? 10 what? Good. And you got to give me both. You can't just say 10. I understand that 10 is the number, but you got to tell me which one it goes with. Does it go with decigrams or does it go with grams? So 177 decigrams. By the way, deci, lower d. Deca, capital D. Okay? Didn't make up the system. I'm sorry it's confusing, but that's what you have to know. Okay? So now I make a fraction. What goes on the bottom of this fraction? The 10 decigrams. The 1 gram on top. Deci and deci cancel out. Do I multiply or divide by 10? We divide by 10. 17.7 grams. By the way, ladies and gentlemen, no naked numbers in my class. Naked number is a number without a unit. Okay, save that for math. Math has numbers without units. Science does not. Every number that you write will have a unit with it. Why? Because every number that you're writing is a measurement. It describes something. Okay? In math, they will talk about 5 times 50. In science, we will talk about 5 centimeters times 50 centimeters. Everything is measured. Questions? All right. All right. Oops. Sorry. Now, what do you do if you're going from a prefix like centimeters to another one like millimeters? Well, ladies and gentlemen, your problem becomes 2 steps. Because I have no way of knowing how many millimeters are in a centimeter or how many centimeters are in a millimeter. I'm not going to make you know that. I'm not going to make you remember it. If you know how many centimeters are in a millimeter, you can make this 1 step. If you don't, you have to make it 2. So the 2 steps that I have to make it, ladies and gentlemen, are I go 100 centimeters equals 1 meter and 1,000 millimeters equals 1 meter. Now, I'm going to do the same thing I just did, but I'm going to add a second step. Why? because I want to go from centimeters all the way to millimeters. So I still, ladies and gentlemen, take this and make a fraction out of it. 1 meter on the top, 100 centimeters on the bottom. Why? Centimeters cancel. But then to get to millimeters, I use this fact. 1,000 millimeters equals 1 meter. Now, why does the millimeters go on top? Because the meters has to go on the bottom to cancel here. 2 steps, same thing you're just doing, just adding one more step to it. Okay? Where did I get these from? The chart in your notes. You get those from the chart in your notes. Now, ladies and gentlemen, we have about 15 minutes left to class or so. The tables in the back are yours to use if you want. If you want to get in a group of 2, if you want to get in a group of 4, if you want to get in a group of 10, I don't care. If you get stuck, you raise your hand, you call me over, I will help you or your group. But you now have time to practice these and work on these. Please go to work, ladies and gentlemen, and if you have any questions, please let me know. Okay? If you're not sure where something is coming from, and I know it's easy to sit there and go, yeah, I got it. When you go on your own, it's like, oh, I don't remember. Call me over. Okay? Go to work. Go to work, go to work, go to work.
Longest time it's so close to 2.
You see this?
That's a strong. Guys, right now, the mutual last class ever.
Questions? Please remember, answer keys are online if you want to see how the problems are working out to make sure you're doing them right. Or you can simply call me over and I will tell you if you're doing them right. Coming right. Yes, sir.
I'm a little bit confused how you got this, like how you got these.
Okay, so you know where this came from, right? Okay, so all I did was take 58 times 1 and divide it by 100. When you do that math, that's what you get here. Now, again, I technically don't have to take it times 1 because what is 58 times 1? So if your number that's not a 1 is on the bottom, it means that's the number you divide by. If the number that is not a 1 is on the top, like if it were 100 up here, then you would multiply by it.
Oh, so you'd like, if it was 100 on top, it'd be like 58 times 100 divided
Correct.
by 1.
Correct.
So you're always multiplying by the top and dividing by the bottom.
Correct. But in most of ours, not always, but right now most of ours, 1 will be in one of those 2 spots. So 1 will either be on the top or the bottom, which means you can put it into your calculator and you don't have to. Because when you multiply by 1, it doesn't change your answer. So you can just save the time and do 58 divided by the 100, and it's on the bottom.
So
Okay.
just always multiply by top and divided by bottom.
Correct. Always. Yep.
And then, and you want to put like, you want to like match these.
Correct. That's how we get the units to cancel. So because I want to get out of this unit, I put it on the top here and I put it on the bottom here. These units then cancel. And then I'm left with this unit and whatever number I get from the math. Okay? All right. Okay. Your first one is right here. But this one, you wanna go to millimeters. So this conversion right here, you're gonna use here as well. Okay? So this one you're gonna use here as well. So this first one is correct, but now you use this one the second time. Okay? So you got 1 meter on the bottom, which is what we want to cancel, but on the top here would be the 1,000 millimeters. Okay? Because if you use the same conversion back again, just flip it, you're not gonna change it. Because you're gonna divide by it the first time and multiply by it the second. That's why you need to use the second different conversion the second time. Okay? Yeah. Okay. So here's what I'm gonna say. C8. We're gonna multiply it by 1 and 1,000. Okay, so you're gonna calculate. Okay. You can use calculator. And then we're gonna go back by 10.
This is everything.
So ultimately, when you have a two-step problem like this,
Well, I mean,
you're gonna take this number, multiply it by not a 1. But there's no reason to multiply by 1. And then you're gonna divide by Okay, what don't you get? Okay, so what we're doing is we're trying to get out 1 unit into another. Okay? To do that, I need to know how many of 1 unit is equal to. So 100 centimeters is equal to 1,000 millimeters. Okay? So if I get centimeters, and I want to get to millimeters, I'm going to use these two steps. Why? I don't know how many millimeters are in some of this. Okay? So, because it's in centimeters here, we want to take this and make a fraction. No, you take the number of this same unit. So that's why we say. Okay? So 100 goes with the centimeters on the bottom, and 1 meter goes on the top. Okay? What this does is it allows me to say this unit and this unit cancel. Not in the unit. It would be in this unit. Okay? But the number also changes depending on how I can find out by 100. Okay? Understand what I'm doing? On the bottom, right? So 0.46 times 1 divided by 100. That would be the max number, correct? Okay? But I don't want to stop there. So I use this back here to set this up. But now that meters is the unit over here, correct? So that's the unit that's So these units. Now I got millimeters. That's the unit. So that's why I choose these two. Get out of the unit I'm in. Take this one out. To get into the unit I'm in. Now, the ones we did before this were only one step. So this is as hard as these problems is two step. Now, mathematically, what you're gonna do is I'm gonna ignore ones. So I'm gonna take 746, which is my calculator. You're gonna multiply by 1,000, on top. And I'm gonna divide by 7. So, when you do this, the first thing you're gonna need to know is this. That's the meters equals 1 meter. And then you're also going to do 1,000 millimeters equals 1 meter. That's the meters here. Use this one to set up a fraction. Oh yeah, because it's on the bottom. Oh my god.
I'm doing a lot. I'll be finding.
This one. To get out of this unit. Oh, 1,000 millimeters. That's the fact.
Oh,
Okay, but you set up. This cancels here. This cancels there. So that means you've set up that. What you can't do is what you try to do is erase the and then, because then you're saying 1,000 meters is each to 1 millimeter. Alright, this is what it is, right? This is what the relationship. Hang on, let me do this, I'm gonna give you what you need in the last one. Just so that you have this one, so you can do that last one. Okay. How we doing?
I am.
You're all on. He said he hates this.
Honestly,
See, you're confusing yourself. Later on, when we get into some other problems, we may talk about that. But for right now, this number always on.
Multiply by this and then divide by this.
Okay?
Because he was more than one.
So if you want to think of it that way, you can do it that way. And then that way, that's always on top of the next fraction. You have to make sure the unit that's on top is on the bottom of the next one. Okay?
8 times 1,000 is 8,000, right? Then you divide it by the 10. Okay. Yeah.
Tomorrow we'll take a look at this when you come in at the start, ladies and gentlemen. Here's the thing. Look it over. If there's other ones that you have a question on, ask, and we'll make sure we do those in class for you tomorrow as well. Okay? Have a great day, ladies and gentlemen. We'll see you tomorrow. Have a good one. Thank you.
Well, they gotta take attendance and shit. That's just why. I'm not trying to give my child.
Now you're going to advisory. Going to advisory now.